Okay, Swiatkowski here. Welcome to another video. In today's video, we're going to be doing our study guide for the Unit 6 test. So it says, rewrite each expression in simplest form. We're rewriting radicals. So here, I know that 72 has a factor of 36 in it. Square root of 36 is 6. This would simplify to 6 root 2. In the next problem, I can take the radicands and actually multiply them. So this is the same as the square root of 36 with that negative sign outside, which would just be equal to negative 6. Number 3 will be similar to number 2, except instead I will divide the radicands. And 75 divided by 3 is 25. Square root of 25 is 5. Number 4 would be like an honors only problem. Here I have to rationalize the denominator. So I multiply by the square root of 15 over the square root of 15. These cancel, or they don't cancel, the radical cancels. And then I get 3 root 15 on the top. And then I can reduce 3 over 15 is 1 over 5. So I get the square root of 15 over 5. All right, now I'm going to use some exponent rules. This is, first I'm using the product rule. So 4 to the third power times x to the 2/3 to the third. 4 to the third is 64, and here we multiply 2/3 and 3, so the 3 would cancel with the 3 in the denominator, so I get x squared. Last one, similar idea. I first use the product to a power rule, so negative 9 to the negative 1/2, or I'm sorry, 9 to the negative 1/2 times x. I'm going to multiply, well, no, I won't do that. So what I did is each product gets raised to the negative 1/2 power. And now, this would be x to the negative 3. So I'm going to put it in the denominator and make it positive. This, since there's a negative here, it would, when I multiply negative 2 times negative 1/2, I get 1 positive, so y would stay in the numerator. And then this goes to the bottom, and make it positive. 9 to the 1/2 is the same as the square root of 9, which is 3. So this is going to be my solution, or my answer. Okay. Rational exponents. This is x to the, this goes in the numerator, this goes in the denominator. Y to the, this is a 2. 6 over 2, which is equal to y to the third. I'm doing the opposite. The denominator is the nth root, so this is the cube root of negative 27 squared. That's negative 3 squared, which is 9. And this would just be the 6th root of z. Okay, let's look at some graphing problems. So the transformations, h would be 2, k is 4, a is 1, and n is 2. This is coming from y equals a times the nth root of x minus h plus k. Remember, it's centered at hk, so that would be 2, 4. And my graph will look something like this. So now the domain is going to be from 2 to positive infinity, and the range will be from 4 to positive infinity. All right, let's do another one. So same parent function I'm using. A is -1, so it's going to have a reflection. N is 3. H is 0 and K is 6. 0, 6. And instead of it looking like this, it gets reflected. So it would look like this instead. 1, 2, 4, roughly. Okay. Remember, for odd root functions, the domain is always -infinity to infinity, and the range is also -infinity to infinity. Okay. So we're going to create a square root function with this domain and range. So this would be our h. This would be our k. So we can make it like this.
Yes, it is 6. I got it right.
And that's it, because k is 0. Cube root function that shifts, that stretches and shifts up. So let's make a some number greater than 1 and then shift it up. That would work. All right, write an equation that models g of x. So here's g of x. Looks like it's a square root function. It would have a shift of 2. Or well, we don't know what a is, but let's see how to do it. So it's going to be x minus 4 plus 0. And I know another point, 5, 2. So I know when x is 5, the output is 2. So I need to figure out what a would be then. X is 5, y is 2. That's 1, so square root of 1. So this means a equals 2. So we'll erase this a, and we'll put in the 2. Got to remember to use that point to... Alright, sorry about that. We got interrupted by an announcement. Moving on to number 16. So I'm going to skip solving this graphically. You can do it on your own if you'd like. You would put one side of the equation into a graphing calculator or Desmos, the other side into another line, and then figure out where they intersect. As far as algebraically, I would get 2x minus 1 plus 2 equals x. So I start there. I'm going to isolate my radical. 2x minus 1 equals x plus 2. Square root of, and then I square both sides. I get 2x minus 1 equals x squared plus 4x plus 4. And then I'm going to pull everything to one side, so this would be x squared plus 2x plus 5. Did I make a mistake here? Yes, I did. This should be minus. This should be minus. Gosh darn it. And then minus 6x plus 5. Factors of 5 that add to negative 6 are negative 5, negative 1. If you check for extraneous solutions, 1 is going to be extraneous, so you cross it out. X equals 5. Now you know. In number 17, I'm going to cube both sides. You get 2x plus 1 equals 125. 2x equals 124. X equals 62. I'm going to leave number 18 for you to do. First step, you would add this radical to the other side. You get 7x minus 8 equals 3x plus 4. You'd square both sides and solve. I will do one of these last problems as well. They're the ones with the rational exponents. Add 2 to both sides. You get 8. Raise each to the reciprocal power. So here, those cancel out when you multiply them. You get x plus 3. And this is the same as the cube root of 8 to the second power. Cube root of 8 is 2. 2 to the second power is 4. So x equals 1. I'll leave number 20 for you. We're going to stop the video there. I'll catch you in the next one.